What's up, guys? What's going on? Today we're looking at 9.4 piecewise functions. Hey, I want to tell you to remember, man, we're holding that whole contest where, if you get a perfect 100 or higher, all right, a perfect 100 or higher, come see me, bring me your test, all right, and I got something for you regardless of the class that you're in, all right? All right, let's jump right in. I'm looking at piecewise functions, so of course this first blank is going to be piecewise, all right? All right, piecewise function. All right, so we talked about it, man, but a piecewise function is a combination of one or more functions. All right. Next right here, guys. All right, a piecewise function that is constant for each interval of its domain, such as a ticket price function, is called a step function. All right, step function. Okay. Now, the way I view this as is you're just looking at the graph. You're just looking at your intervals from -2 to 4. All right. Well, the first thing, let me backtrack. I want to review with you guys is you guys learned somewhere in your math career about number lines. All right. And with a number line, if you were to graph a value in inequalities and it was less than or greater than, all right, it was some x that was less than a number or some x that was greater than a number, you always graph that with an open circle. All right. But on the latter side, let's say you graphed some x that was less than or equal to a number, or you graph some x that was greater than or equal to a number. You graph that using a closed circle. All right. So open circle is just less than or greater than. Closed circle means greater than or equal to, less than or equal to, or greater than or equal to. All right. Now, the next thing I want to talk about is these intervals from -2 to 4. Y'all see how there's an x in the middle? This defines x. All right, x is being defined right here. So this is not x, guys. This is x. These are your intervals of x. All right. So our answer or our function, which is 5 in this case, will exist between -2 and 4. So you go to where the function is, which is 5. Right here, this is 5. Count up 1, 2, 3, 4, 5. All right, and then we go to -2. We got an open circle. All right, and at 4, we have a closed circle. And again, the reason being, -2 is just a less than. -2 is less than x. So there's no equal to, so it's an open circle. But at 4, 4 is greater than or equal to x. All right, there's an equal to. That line underneath is an equal to, which means closed circle. All right, we're going to connect those points. Next, we look at our next function. All right, our function of -2, where does it exist? Between 4 and 6. All right, between 4 and 6. So I go to my function -2. Here's -2, 1, 2. All right, where does it exist? Between 4 and 6. So here's 4, x is 4. Open circle, because it's just less than. And 6, because 2 is less than, 6 is greater than x. All right, and connect those points. And then we go to 7. Our function, is 7. All right, and at 7, it is just between 6 and 9. But see how those are both equal to, so those both will be closed circles. So I go up to 7. Here's 7. All right, go over to 6. Closed circle. 9. Closed circle, and connect those points, okay? 6 to 9. All right, so here's the you try. All right, you guys try that. I'm going to go and slap the answers up here. All right, make sure you try it. All right, for the function -2, it is between -6 and -3. Close circles again because the equal to signs. All right, then you have 1, where the function is 1, from -3. Open circle. That's an open circle, guys. Sorry about that. To 4, close circle, because it's equal to. All right, and then we have 6. The function equals 6 from 4 to 9. All right, so I hope that clears that up for you guys involving step functions. All right, let's go ahead and look at this here, guys. Right here we're evaluating each piecewise function. All right, and evaluating is just that. Evaluate means solve, okay? Solve. All right, so now we're gonna solve this function for x equals 1, -1, or x equals 4. All right, well, we look at these two functions, all right, and we look at their conditions. All right, for this first one, 2x plus 1. If x is less than, now let's review that, guys. All right, some of you guys still are having a little difficulty. And the rule I learned in elementary school was the alligator gets the bigger half, or gets the bigger side. All right, y'all see how right here, the x gets the smaller side? Well, that means less than. All right, if it was like this, that would be x is greater than, because x has the larger side. Here, x is less than. All right, x is less than, x is greater than. All right, if you had a value here, all right, another way you could say it is 4 is greater than x, because 4 has the larger side. Or you could say x is less than 4. All right, just remember, all right, the bigger side goes to the greater side, okay? Now, to this problem right here. This says if x is less than or equal to 2. Well, we look at our two x values. All right, which one of these would fit this condition where x is less than or equal to 2? All right, so you have to ask yourself, is -1 less than or equal to 2? It is. Is 4 less than or equal to 2? It is not. So we won't bother with the 4 for this top equation, or this top function. All right, we're going to plug in the -1 because, again, -1 is less than or equal to 2. So I evaluated for 2 times -1 plus 1. All right, and that's -2, and -2 plus 1 is -1. All right, so that's the solution for this first function. Well, for this one, we have to evaluate it for if the x value was greater than 2. Well, is this first x value here greater than 2? It is not, so we do not use it. Is this x value greater than 2? It is. So we will substitute that in for x. So we have 4 squared minus 4 equals, let's solve it. This is 16. 4 squared is 16, minus 4 is 12. All right, so there's our solution for the second problem. If you scroll on over, all right, same x values, we're going to use the same x values for this. All right, so let's see. For this one, 2 to the x, if x is less than or equal to -1. All right, so which one of these values will be less than or equal to? All right, because there's an equal to sign right there. The -1, it will be this one, of course. All right, -1 is equal to -1, so we evaluate that for 2 to the -1. And remember the rule, guys, when you have a negative reciprocal, just move it to the bottom. All right, so 1/2. Or some of you guys put 0.5. 0.5 is okay. All right. Now, the next one says the function is 5x, all right, where x is greater than -1. So not equal to, but greater than. Well, we can't use that one because -1 is not greater than -1. All right, but 4 is greater than -1. So we're going to do that. 5 times 4, and that equals 20. All right, so we just evaluated those two functions. Now let's talk about absolute value. All right, I don't know how your teacher taught it, but I'm going to teach it a little different. All right, if they taught it my way, then awesome, okay? But there's a couple different ways to look at this thing, and I hope my way makes sense. If it confuses you, my apologies. All right, make sure you stick with what your teacher, if you understand it, stick with what your teacher taught you. The first thing we do, guys, is we're going to solve, well, no, actually the first thing we do is we find our x value of the vertex. All right, so here's the vertex right here. All right, so we just identify the x value. All right, so to identify the x value, 1, 2, 3, 4, 5. That's -5 right there. All right, so this is -5. Now, what we do is we take our equation, all right, and we solve it for a positive, what was it, x plus 5 minus 4, and a negative. All right, sorry about that, put the parentheses right here. All right, and the reason we do that is because it's an absolute value. All right, so now we solve both sides. This right here, distribute the 2, so you get 2x plus 10. 2 times x is 2x. 2 times 5 is 10. minus 4. And then we simplify, combining like terms. Well, 10 minus 4 is 6. So 2x minus 6. Excuse me, plus 6. 10 minus 4 is 6. So 2x minus 6, okay? Over here, we evaluate this side. All right, negative 2 times x is negative 2x. And negative 2 times 5 is negative 10. All right, bring down to minus 4. And then simplify like terms. You have negative 2x minus negative 10 minus 4 give you negative 14, okay? So now, here are our two equations, okay? Here are our two equations. Now, before we use those, there's a couple things we got to look at for our piecewise function, all right? For our function, a couple things I want you to remember. Here's negative 5. If I go to the right, guys, all my x values will get bigger. See, that's negative 5, negative 4, negative 3, negative 2, negative 1. Those are larger numbers than negative 5. All right, so we're going to say that x is larger or greater than negative 5. All right, then as we go this way, all right, we say that all the x values are less than negative 5. See, like take negative 9. All right, here's negative 5. All right, here's negative 9. Which one's larger? This is larger. All right, so we say that x is smaller or less than negative 5, okay? Now, we have a case where one of these are going to be equal to. All right, one of these have to have the equal to sign. All right, don't write that down, but one of those have to have an equal sign. Well, let's figure out which one has the equal sign. All right, and here's what we do. See how this opens up? All right, because this v, or this absolute value function opens up, that means that this is positive. All right, there's a positive in front. It's not a reflection. There's a positive here. Since this is positive, the positive side, all right, leaving from the all the x values that are in the positive direction or to the right, will be equal to. All right, so this function right here represents the positive side. X is greater than negative 5. So this is going to be x is greater than or equal to negative 5. Okay, that is why this is an equal to, guys. This thing opens up, so the positive side, the positive side gets the negative 5. The positive side gets the the equal to sign. Okay. So now that we address that, let's look at the slope of the line. Okay. Take a look at this line right here. See how this line right here is going in a positive direction? All right. This line is going this way. All right. The thing I want you to notice is that right here, that's your y-intercept at 6. All right. Well, I want you to look back at your equations. We can see the y-intercept. All right. This line right here travels to the right. All right. I know it's going up, guys, but in terms of x values, the x-axis, this thing is going that way. All right. So these two equations are written in what's called slope-intercept form. All right. Oops, forgot my R. Now, this and this are your y-intercepts. So check this out. Which equation right here has the slope of 6? Excuse me, the y-intercept of 6. That would be this equation right here. All right, this equation has the y-intercept of 6. All right, so this equation matches this side. All right, but the thing I want you to remember is look at the equation. All right, which one of these equations represent traveling this way to the right? All right, and if you remember, x right here is going to be greater or equal to negative 5. All right, so that would be this first one. All right, so this equation right here, 2x plus 6, goes with this function. This condition. All right, and this function right here, all right, will go with this condition right here. Okay, all right. This one goes to the slope, okay? Because this line right here goes to the right with this condition, that tells me that they need to be together. All right, so x greater than negative 5, all right? And this equation that has that slope goes together, which means, of course, this one goes with the other one, okay? Let's take a look at the other problem. Again, first thing, identify your x value for your vertex. So we have 1, 2. All right, this would be negative 2, right? That's the x value. And then we're going to take our equation and we're going to solve it. All right. So we have negative. Remember, you got to have a negative. And you got to have a positive. All right. So right here, distribute the negative. You get negative 3x minus 6. Combine like terms, negative 6 plus 1 is going to give me a negative 3x minus 5, right? And over here, well, there's nothing to distribute, so it's just 3x plus 6 plus 1. Combine like terms, you get 3x plus 7. All right. Now, the next thing we need to do is look at our conditions. All right. With our conditions here, as x goes this way, again, what are the x values doing? They're getting larger. All right. So x is larger or greater than negative 2. And as x goes this way, x is smaller or less than negative 2. Now, before we do anything else, we got to figure out which one of these signs are going to get the equal to sign. All right, the line underneath. All right. So, how we figure that out is this. Look at the direction. See, that's negative? All right, let me move it up a little bit. See, that's negative? Or you could say because it's open down. All right, that means that because it's open down or the negative direction, all right, to the left, all right, we'll have the equal sign. So see how this is x is less than negative 2, which is that way? That gets the equal sign. X is less than negative 2. All right. Now we got to pair up our equations, all right, or our functions, our slope-intercept form. So let's look at the y-intercept we can see. All right, this one right here, we can see that one. That's negative 5, right? So which one of these have a y-intercept of negative 5? It will be this one. All right, this one. So now you got to ask yourself, which direction is that line traveling? Is that line traveling left or right? All right. That line is traveling to the right, like so. All right. To the right, like so. So which equation was this? It's traveling to the right. All right. X's are greater than negative 2. So this function with the y-intercept of negative 5 goes in the same direction as that condition. All right, so we're going to rewrite that as x, or excuse me, negative 3x, my apologies, minus 5. All right, that will satisfy this right here. Okay, and then, of course, the other equation, all right, will be this line right here. All right, that's your piecewise function, guys. Okay, now, let's continue. We got some u-tries right here. All right, this first u-try, this is more like a step function because remember the step functions over here, you had whole numbers, all right, as your functions. All right, so take this first condition, all right, where x is greater than, excuse me, less than, x is less than or equal to negative 1, all right, at 4. So I go to 4, all right, and for the answer to be 4 or for the function to be 4, it has to be less than or equal to negative 1. So at negative 1, I have a closed circle because of the equal to. And it tells us less than negative 1. So which direction do I go in to have less than? All right, the x's will go this way. That's less than. And right here, x is greater than negative 1. All right, for the function to be negative 2. So at negative 2, the functions are greater than negative 1. So at negative 1, I have an open circle. All right, because there's no equal to sign. I travel that way. All right, to the right. Greater than is to the right. Next, looking right here, we have find f of a negative 2. All right. Now this is the x value. You guys know f of x, all right, equals y. Well, x, that's my x value right there. And we're trying to figure out what the y is going to be. All right, what the y is going to be. I don't want that to be division, so here, let's move that. I don't want anybody to think, oh, that's division. No, it's not. All right, what I'm saying is f of x equals y. Well, x in this case is negative 2. All right. And if you look at your graph, guys, see that's 0, and that's negative 2 right here. So if I go 1, or excuse me, 0.5, negative 1. All right, negative 1.5, negative 2. All right, but anyway, x is negative 2. So I plug in negative 2. Well, look at the function. Where's the function? Right here. All right, what's that value? 0.5, negative 1. So this would be negative 1, guys. All right, x is negative 2. What is y? Negative 1. All right, and over here, if f is negative 1, so here's negative 1. Well, where's the function? It's not down here. There's no graph here. If I go up, there it is, 2. All right, the function where f is negative 1, the y is 2. All right. So there you go. That is the notes, okay? I hope this helps, guys. I really do. Take a look at it. Try to practice through some problems, and we'll have a good practice day tomorrow. All right? Hey, again, if you get a 100 on your test, come see me. Hey, if you like this video and it helped, man, please give me a thumbs up on it, all right? And subscribe to the channel so you can continue to get the messages. I mean, you can get the video, you get a message about the video link, all right?